Good. Hello, everyone, once again. Thank you very much for inviting me to this event. I am very happy to be able to share my knowledge and experience with you today. And I also miss very much meeting all the people offline. I kind of got used to sitting in my bedroom, talking to people and working like this, but I really miss all the opportunities I used to have in the past before COVID. So yeah, but this is the today's reality. Okay, without further ado, let's get to the presentation then. Today we are going to talk about the impact that the concurrency control can have on our APIs. And in modern software systems, it is not uncommon to have like hundreds or thousands of users independently and concurrently interacting with our resources. And what we generally want to do is to avoid situations when changes made by one client are overridden by another one without even knowing. So in order to prevent our data integrity from being violated, we often use locking mechanisms, often provided by our database engines, or even we use abstractions provided by tools like JPA, for example. The question now is, how does concurrency control impact our API? What error codes do we use? What headers do we use? Does HTTP protocol support such cases at all? And finally, how to implement the API according to ART with the help of Spring Framework? How much support do we have from Spring Framework and how much we need to do on our own? And during this talk, we'll answer all of these questions. One vital thing to be mentioned before we start, what this talk will not be about. So we won't be talking about locking mechanisms, about transactions, about isolation levels. We will just focus on the API. So maybe before I start start moving forward with my presentation and with showing you some code samples and live coding, of course, I will tell you a bit about myself so that you know who is going to take an hour of your life. So my name is Bartłomiej Słota. As you have already heard, I'm a consultant, I'm a trainer and mentor, and of course, actively programming software developer. I'm also a public speaker and I blog from time to time. I have gained experience working in numerous industries, starting from healthcare through telco, marketing, finance, energy, for companies of sizes from tens to thousands of people. And I am very passionate about object-oriented programming in general, domain-driven design, software craftsmanship, microservices, and software architecture. And I am also an enthusiast of event storming workshops. And apart from my professional life, I also have a personal one. So I'm a very happy husband and a father. I love heavy metal music. I play guitar. I love angling, trekking, and that's all. We can go to the next step of our presentation. So what you can see on the slide now is kind of a result, part of the result of the event storming workshop, and the use case that we will be working on during this session is the automated process of placing books on hold by patron clients in the public library. And for the sake of simplicity, let's assume that each book can be in one of two possible states. The first state is available, and second one, placed on hold, reserved in other words. Now, a book can be placed on hold by patron only if it exists in the library and if it's currently available. This is how it could be modeled during the event storming session. And each patron can place the book on hold, send a command. and in order to make such a decision, he or she needs to see the list of available books first, or see the details of particular book. So we could say, using the a bit more technical nomenclature, just view a read model. Now, depending on the book availability, will either allow or disallow the process to succeed. Now, let's have a look how this look like in the code. So the most important place that we will be working on a lot during this presentation is book holding controller. And in this book holding controller, we expose a patch method for /book/book ID path. And what we have here is that you can send a request body that defines the status to which we want to move our book to. And if it is placed on hold, so whenever we want to make the reservation of a book, then we pass the logic to our application service. And what happens here is that we try to find the book in the repository, do what's necessary, and save the result. And it's as simple as that. And if everything goes fine, we just return no content. What else do we have? Of course, we need to let our users, let our clients see some details of a book. So we'll be also working a bit with the book finding controller, which exposes the get method for the same path as we had before. And this time we're just returning what we find in the repository. We of course are transforming this object we find to some DTO, and we also have our domain modeled with available book class, and we have some simple set of fields here and a main method placed on hold that kind of realizes the main part of the logic that we will be working on. And of course, all of these parts are tested, and we have a book API test, which we'll be also working with during this presentation. So before we dig deeper into the code, we need to identify the problem first. So as we already mentioned, it might be the case that two patrons are watching the list of available books at the same time, and they both see the same copy they're interested in, and this copy is available. And both of them are trying to place it on hold. Now, how can we handle concurrent access in our application? And we have two ways of doing so. The first one is so-called full state comparison. What does it mean? In the moment of saving the updated book in the database, we could make a full state comparison with what currently resides in the database. And if the result of the comparison is positive, we can persist the new version of our aggregate as a whole. And these operations that I mentioned, which is comparing and updating, need to be atomic, of course. And the advantage of this solution is that it doesn't impact the structure of an aggregate, which means that the technical persistent details do not leak into domain layer or any other layers above, which is not the case in the other examples. They're, on the other hand, a lot more pragmatic and a lot more practical. And the alternative to the full state comparison is the locking or locking mechanisms. So without going into details, the latter, of course, we have two options of locking: the pessimistic locking and the optimistic locking. And the latter one is preferable when the number of write operations is not that big comparing to read operations. And optimistic locking in general lets every client read and write data at will without the restriction, with the restriction that just before committing the transaction, we need to check if the particular record has not been modified by someone else in the meantime. So this is usually done by adding some version attribute or last modification timestamp attribute. And I would like to point out that what I have been observing is that when dealing with concurrent access, we usually think of the technical side of the problem only. But is this really a technical problem that we are just trying to fight with? Let's imagine a conversation, which we have on the slide over here, between a developer, the lady on the left, and the product owner or someone from business, which represented by the man on the right. And let's imagine that this is what they say. Let's talk about circumstances where two patrons try to place the same book on hold and only one wins. Is there any situation, dear product owner, in which we simply cannot tell our user that she had a bad luck trying to place the book on hold? And product owner might say that when the patron is a premium one, you should send me an email and I would contact the person directly. So we often try to find a copy for him, canceling the reservation of some other patron, or just buying a new copy so the premium customer is happy. This is just a very, very simple example of how to approach this kind of problem. And I really encourage you to always think of the business rationale before choosing any technical solution. So depending on the business, we might need to look into optimistic locking or any other locking mechanisms in one way or another. And in the further part of the presentation, you will see how can we do that technically. So let's assume that we chose optimistic locking to secure ourselves from the lost update problem. What impact on the API do we have? So let's switch to another revision, git checkout talk optimistic locking. And what happens now when we want to apply optimistic locking? What's changed in our code base is that now we have a version class that is just representing the value of the version of our aggregate. This is just a class that encapsulates the idea of the value. And of course, we need to use this value somewhere. And the place that we do so is the available book class. So it is our model. And of course, this version needs to be propagated further down to a repository. So if we have a look at the book entity, for example, we also do have the version attribute that is annotated with the version annotation. So with such a setup, the JPA implementation will take care of the optimistic locking. So far, so good. What do you think will happen when the conflict occurs? This is a framework, so what else should we expect other than an exception? So if we open our repository class, what we see here is that optimistic locking failure exception is something that we expect in case of the conflict. So of course we can map this exception to something more meaningful, like stale state of our aggregate identified for aggregate with some particular ID. But still, until we do something with this exception, Spring Framework will return internal server error to our clients, and it is definitely not something that our clients would like to see. And knowing that it is a possible business scenario that the conflict occurs, should it be treated as an error or modeled as an exception? No, really, this is not an exception. This is a valid use case that two clients try to place the same book on hold. That's a valid use case. So modeling it with exceptions just makes results in having a bigger model code gap. And this is where usually concurrency control ended in projects I've seen. How can we do it better? Okay, assuming that we want to tell our customer that we are just very sorry that we couldn't make the reservation due to the conflict, returning 500 internal server error would force us to put some extra information in the response, right? So that our client applications could have an idea of what was the source of an error, what message should we show to our customer, etc. But fortunately, there's a standard solution for this problem. What is this solution? This solution has been defined in the RFC 7231 Hypertext Transfer Protocol Semantics and Content. And this RFC defines 409 conflict response code. And just let me read part of this RFC. The 409 conflict status code indicates that the request could not be completed due to a conflict with the current state of the target resource. This is exactly what we are fighting with. This code is used in situations when the user might be able to resolve the conflict and resubmit the request. And the server should generate a payload that includes enough information for a user to recognize the source of the conflict. And the last sentence here is very, very vital because it tells a lot about how should we implement that solution in our code. So let's explain it by example. Let's move to the code again, check out. And we're going to start with a test, of course. We have a test, placing on hold conflict. What do we have in this test? We are checking if we signal conflict that happened. Given that we have the available book in the system, and we read this book through our API, so we have kind of a read model. We see the book on our website or whatever it is, some client application, and the book was modified in the meantime by someone else. Then if we try to place this book on hold, we should get the 409 status and all necessary information, all information that are necessary for the client to get the idea of what was the source of the conflict. And in practice, it means that we send the whole state, the current state of a resource. And please note that the last line over here is, in this last line, we do not check the exact value of the version. And the reason behind that is that in this context, in the context of the REST controller, we do not, and it should not care about how this attribute is calculated and updated. And the fact that it changes is enough information. This is how we address the separation of concerns in tests. Now, how to make this test pass? Let's move to the book holding controller once again. Let's move to our application service, to the place where we were handling the conflict. So if we have a conflict over here in the repository, here in the save method, we are throwing an exception. And as I already mentioned, modeling valid use cases with exceptions is not a good idea. So in order to deal with that, I introduced a result interface that has a couple of implementations. So we might successfully place the book on hold, which is one implementation. The book might have not been found. And of course, the book conflict might have been identified. And this is something that we are going to use here. So what we need to put here is try catch over this part. And whenever we catch the exception, stale state identified exception, we need to return new book conflict identified for current state, because we need to return the current state of the book. And what is this current state? Current state equals, this is exactly what resides in the repository right now. So we are going to find the book by its ID, book ID, and for the sake of simplicity, we'll just put null over here in case when the book is not found. But this is not the end of our implementation. When we move to the book holding controller, we of course need to handle that situation over here. If book placed on hold, we return no content. If book is not found, we return 404 not found. And in case of not of a conflict, book conflict identified, what we need to return is status code conflict, HTTP status conflict, and we need to put some body in here, result, current state, and we also need to map this current state into our view model, into our DTO. So we map it to book view. We use the factory method from or else we just put a simple null here. So if I get back to our test, I hope that it passes. And of course, this is live coding and everything might happen, but I hope it will pass. So in the meantime, let's proceed with the presentation, hoping that this will pass. Now, if the consumer gets the 409, it needs to interpret the status code and analyze the content in order to determine what might have been the source of the content, really. And according to RFC 5789, these are the application and the patch format that determines if a customer can reissue the request as it is, needs to recalculate the patch, or simply needs to fail. And in our case, we are just not able. We are not able to perform a retry of a message preserving its form. The reason behind that is that the version attribute has changed. So we just cannot use the same request in the same form. We need to reread the data from the server once again so that we have the version attribute up to date. And even if we applied new version before we sending our message, we need to check the source of the conflict, because we are allowed only to send this request if the book exists and if the book is available. So any other change apart from the status of the book, like title, author, whatever, not affecting the status, would not impact the business invariant. So it will allow us to reissue the request. But in our case, when there's a conflict that that was caused by changing the status of a book, making the reservation of the book, we just simply cannot do that. And in this solution, like you could see this in the code, the domain and the API must contain the version attribute. If the domain has a notion of a version, it is fine. Otherwise, the code gets a bit dirty. And do we have any alternative to the version attribute? We might have. We could theoretically use the timestamp of the last modification of the resource, which might have some business meaning. But to be pragmatic, I usually just add the version attribute, and it is the simplest and the most understandable, I would say, option for developers. Now, but I don't think that you would be happy to sign up for the meetup with me and get back with the information that all we should do is to catch an exception and map it to the conflict error code, right? So let's take a look at our example once again. Aren't we executing a conditional request? Yes, we are, because we have a condition. We allow our clients to update the book only if it has not been modified in the meantime, right? This is our condition. And it turns out that there is an explicit and standard way of dealing with conditional requests in HTTP protocol. And RFC 7232 conditional requests defines this concept, including a set of metadata headers indicating the state of the resource and all the preconditions that we'll be talking about in a second. RFC 7232 distinguishes conditional read and write requests. The former ones are often used for effective caching mechanisms. So we will focus on the latter ones. We are not talking about caching. We are talking about unsafe operations. And the very basic concept of, the very basic component of conditional requests is the ETAG, entity tag header. And this entity tag header should be returned anytime we read a resource with a GET request. So whenever we want to see a read model, we should return this header. And whenever we update it with some unsafe method. So ETAG is an opaque textual validator, a token we could say, generated by the server that owns the resource. And this token is associated with its particular representation of the resource at the current point in time. So it must enable unique identification of the state of the resource. And in the perfect world, every change in both the entity state, we could say response body, or in its metadata, the content type, for example, is reflected in updated e-tag value. One could say, why do we need a special header like e-tag when there is a last modified header and in HTTP? The problem is that the last modified header schema has a limitation. It limits the time resolution to seconds only. And in this situation, when we are talking about the concurrent access and the operations that might overwrite one another, it is simply not sufficient. We cannot rely on a second resolution. Okay, we'll start describing e-tags from its validation, its standard generation, not by accident. The way in which we create this header depends on a chosen way of validating it and validating the preconditions. And there are two types of validations: strong one, which is the default option, and the weak one. Entity tag is considered strong when its value is updated whenever the content of particular resource representation changes, and it is observable in 200 OK response to GET request. And it is crucial, it is extremely crucial, that the value is unique between different representations of the same resource. So if you have like the same endpoint, but you return JSON or XML, the entity tag in the strong version should be different. There's an exception from that rule. You might have different content types in terms of the name of the content type. Just to give you an example, you might have content type like application JSON and other content type like application, vendor, company, category, JSON, something, that are both identical in terms of serialized form of the response. Then if the serialized form of the response is the same to in both cases, they can share the same e-tag value, forcing, we need to of course force different values to be used in all other cases. Now, when can we use weak e-tags? E-tag is considered weak when its value might not be updated on every change of the resource representation. The reasons for using weak e-tags might be dictated by some limitations of the algorithm that calculates them, but this is just a theory. In practice, I haven't met situations when it was hard for us to generate the e-tag. So answering the question, which e-tag should we use, really depends on how difficult it is for us to generate it efficiently. Weak e-tags are considered easier to generate, but less reliable in terms of resource state comparison. So the choice should be dictated by the specific of our data, types of supported representation media types, and what is most important, our ability to ensure uniqueness across different representations of a single resource. But practically and pragmatically, using the version attribute, which we'll do in a second, is something that is a very efficient way of generating a strong e-tag. We'll see that in a second. Now, e-tags are generated according to the formula you can see on the slide. And the e-tag is just a concatenation of the optional w/weak validation indicator and an opaque tag surrounded by double quotes. And you can also find some examples on the slide. The question is, what should we put into the e-tag, into the opaque tag value? As you already mentioned, it can be a version number combined with content type classifier. It can be some hashed value over response. It can be also a timestamp that has subsequent resolution. Okay, let's start with some coding then. Let's move to another revision. And of course, we are going to start with some simple tests. So this test checks if we include the E tag based on the version attribute in the book view response. So assuming that we have some version and we have an available book in the system with this particular version, when we read the book from our API, we expect the response to contain the E tag header containing the version attribute surrounded by double quotes. How can we provide that? Let's open the book finding controller, because we're now talking about how to return that thing. And it turns out that Spring Framework has a very good helper method in our response entity builder, which is called etag. And what we can put here is string value of it get version. And this is as simple as that. And if we run the test, I hope it will pass. The good thing about using this helper method is that we do not need to care about adding, all this double quotes and stuff. So Spring Framework will just take care of that. And having the E tag value returned, we no longer need to pass the version attribute in the response body, because now it is included in the header. So we don't need to duplicate this information in two places. So we can see that Spring Framework delivers an API in the response entity builder to return the entity tag. And let's see what about the rest. The preconditions. We know what E tags are, how to calculate them, and how to compare them. But now it's time for conditional request. In order to create a conditional request, we need to utilize the E tag returned by the server and put its value into one of conditional headers. What conditional headers do we have? The RFC 7232 define those. If match, if not matched, if modified since, if unmodified since, and if range. And headers that are relevant from the perspective of unsafe methods, because we are not dealing with caching, once again. The unsafe methods, we only care about if match header and if unmodified since. And since we are not working with dates, we only will use and focus on the if match header. Now, regardless the header we are going to use, we need to know when should we evaluate conditions embedded in these headers. And here's what the RFC tells us. A server must ignore all received preconditions if its response to the same request without those conditions would have been a status code other than 200-ish or 412 precondition failed. In other words, redirects, failures take precedence over the evaluation of preconditions in conditional requests. Now, in English, it means that if we have any validations on the server side that end up in error codes like 404, not found, 422, unprocessable entity, or 400-ish messages being returned, we should perform those validations first. We need to remember, though, that the precondition checks must also take place before the actual method semantics on the target resource, right? The idea of if much header is that we give the server information about what representation of particular resource we expect the server to have, and if much header in our case should be equal to the current version, the current value of the E tag. And how can it look like on the web sequence diagram? So whenever we get the book, we try to read the book, we get the response with some E tag value, and we have two alternatives. If we put the same value here into the if much header, trying to execute the patch method to execute any unsafe method, we expect it to be successful. No content in our case. And if we put something bad, some incorrect E tag value, we expect to get 412 precondition failed. Okay, let's try to code it. Let's move to our code base once again. Git check, git reset. Okay, and of course, again, we are starting with some with some tests. The first test that was added in this example is that we should successfully place previously read book on hold. So if we have an available book in the system with some particular version and we read the response, okay, something went wrong with Maven. I will re-import the project. Hope it will help. Yeah, strange thing. Okay, we are here. We get the response from our API. We read the book view. We get the e-tag value. And whenever we try to place the book on hold, send the command of placing book on hold that contains the if match header that is equal to the e-tag value, we expect to get no content, which is something successful. I expect this test to pass because until now we had what we have in the code is I mean, there are no checks for any headers. We don't expect the if match header to be included in the request. So I expect this test to pass. But the test that I expect to fail is the one that checks if we return the precondition fail response when we try to make the change with some wrong or stale e-tag. So assuming we have some available book in the system and we try to use some stale e-tag and we send the command with the if match header containing the stale e-tag value, we expect to get 412 error message. Okay, so how to make these tests pass? And to make sure that I'm not lying to you and the last test doesn't pass, I'll just run them. And in the meantime, I'll try to show you the implementation. Okay, what we have not spoken about is forcing, or it is about forcing clients to use preconditions. So in order to keep the backward compatibility, we'll add second method that will just interpret all the patch requests that contain if match header. So if we have such situation when we want to add another type of functionality and we are not sure, or we just don't want to force all our clients to update their API, update their code, we need to keep the backward compatibility. And this is what we are going to do now. So if someone hasn't been sending the if match header so far, we do not force that. If someone wants to do so, it will be handled separately. Don't worry about the code duplication. We'll get rid of that very, very soon. So in this case, I just don't expect to have the if match header, okay? But in the other case, headers, in other case, I want to have that. I want to have that header, and of course, I want it to be passed here as a parameter. So request header that is named HTTP headers if match e-tag. Okay. The question now, the question you might ask now is, what is this e-tag? Is this something provided by Spring Framework? No, it is not. Actually, it's high time I said that. Actually, the moment when we return the e-tag is the moment when Spring Framework and its support ends for managing conditional requests. This e-tag class is something that I wrote for the purpose of not only this presentation but also production code that I wrote for my customers. And this is something that you may use. You may find it on my GitHub account. Actually, the whole project is on my GitHub account. You can find it there. You can use it however you like. You can apply it to your application if you like. I'm completely fine with it. It is open source anyway, so you can use that. This class encapsulates all the logic related with handling, this double quote stuff. Handles adding this w/validation flag, etc. And it has some very useful helper methods to deal with this e-tags that we that we get here is actually if match header. And what we should do now in this situation, we want to, if it's of course placing it on hold, we need to get the version attribute from it. We need to parse this if match header version from if match. Actually, we need to put long here as far as I remember. Yeah, long parts long from if match get trimmed value. This is one of these helper methods. I'm removing all these double quotes from the header, and I use this version over here. I no longer want to look at the version attribute that I passed in my request body. Now I'm using the header. And is this all? Not really, because I don't want to return the 409 conflict response code. I want to return something else. So for the sake of simplicity, I'll just make a copy of it. And this method I will just rename for build, say conditional response 4. And now I don't want to return that. And instead, I want to return HTTP status precondition failed and build. And that's all I need. Okay, do I have everything here? I hope so. And let's rerun the whole suite of tests, actually. I can run all of them, hoping they will pass. And what you can see now is that now we introduced like two possible versions of handling conflicts. One with returning the 409 and forcing our clients to find the reason of the conflict. Now we are telling explicitly that preconditions have failed. What preconditions? It should be stated clearly by our business use case. So returning 412 error message, error code is much more meaningful. Again, this test didn't pass, and it happens sometime. So I probably missed something yet, and I know what I missed. And here I should use the method I wrote, basically, over here. And if I rerun the test that failed, it should pass. Now, okay, now here we reach the moment when we need to decide whether we really want to keep this backward compatibility, keep these two solutions alive and running in parallel, and maybe we want to use only one and force our API clients to use conditional requests. And it turns out that there is a possibility of forcing our clients to do so. Let's check a second. Yeah, the test is green, so everything is fine. And it turns out that there's an RFC 6585 additional HTTP status codes that define 4 to 8 precondition required status code that indicates that the origin server requires the request to be conditional. And its typical use is to avoid a lost update problem, where a client gets a resources state, modifies it, and puts it back to the server, where meanwhile a third party has modified the state on the server, leading to a conflict. And this is exactly what we are trying to fight with, right? So how could it look like in our web sequence diagram? So whenever we get our response, our view, including the E tag, if we do not include the E tag, we just expect to get 4 to 8 preconditions required. How to put it into the code? Let's do it and see. Git reset, git checkout preconditions. And again, of course, we are always starting with writing a test. I hope you already got the habit after this presentation. Yeah, and the test is that we should signal precondition required when if match header is missing. So assuming we have some available book in the system, and whenever I try to send the place on hold command for some book without the if match header, I just expect to get the is precondition required, the precondition required status, and get some error message saying that if match header is required. And how to make this test pass, to make sure that it do not pass now, I'll just run it. And let's move to the book holding controller once again. And like I said before, now we don't want to distinguish these two situations. We only care about the situation when we pass the header. But we need to remember how Spring Framework really works. So if I put the parameter here like this, and Spring Framework does not find this header in the request, it will return 404, not found, which is not something that we expect. We want to return 428. So we need to do it a bit differently. So let's get rid of this older method, and let's get rid of this one. So we just remove the duplication. We expect to get all the headers, but here what we need to add is the required attribute. So we do not require this e tag to be present always. And what to do next? Of course, it can be null. If it's required, it can be null. So if it is null, optional of nullable, if match. If it's there, of course, we can do something with it. And what we do with it is exactly this. So let's extract it to a method like handle. Let's call it like this. And we are going to map it to e tag handle book ID command e tag, or else precondition required, right? And we put the return keyword over here. And what we are missing is the precondition required method. Precondition required, return response entity, status, HTTP status, precondition required with some body error message from something like this. And I missed the bill. No, everything's fine. So let's rerun the test once again, hoping that the test will pass. Let's give us a second. Come on. It's the final example of the presentation, so it must be green. Yep. All right. So summing up, the concurrency control should always be reflected in our API, especially because the HTTP protocol provides a set of tools to support us in that situations. So the first thing to start with is to add the version attribute into your read model and pass it further to your unsafe methods. And the simplest option for handling conflicts is to just return the 409 conflict status when the conflict is detected. It, of course, requires usually a lot of work on the client side, and a bit more sophisticated solution is to use e tag headers, header or last modified header if the resolution up to seconds is enough, but it usually isn't. And their values should be put by clients to if match or if unmodified since headers respectively. And in case of a conflict, we just return the 412 precondition failed error code. And we can also force our clients to use conditional requests by returning 428 precondition required error code when particular header is missing. So I want you also to remember that Spring Framework supports us only in returning e tag headers, but we have to implement the unsafe conditional requests handling on our own. But fortunately, the API of Spring Framework enables us to do so. You have seen the example. Feel free to use it to have a look at my GitHub project. And I think that's all. Thank you very much for joining the event. I hope you found something useful to you that you could use in your daily work. And if there are any questions, I'm more than happy to answer them. Thank you very much.